Hello, everybody. My name is Andy Rivenis. I'm a product manager for database and memory. Today, we're going to talk about best practices for getting started with database and memory. So what is database and memory? Database and memory is all about analytic workload and improving the performance of your existing reporting applications without having to change any application SQL. Real-time analytics, being able to run your analytic workload right on your operational data or your source data in real time without having to wait for that data to be transferred to, say, your data warehouse or a reporting system of some kind, being able to answer questions in real time from your data. And then reduced overhead. Since database and memory doesn't use analytic reporting indexes, very often you can drop those analytic reporting indexes and gain a considerable amount of capacity and significantly reduce your overhead for your transactions because they no longer have to maintain all of those indexes. And Oracle's traditionally been a row format database, and row formats are great for transaction processing. All of the column attributes are together in a single row in memory, and they can be operated on very quickly. However, it's slower for analytics because you have to look through all of those rows and column values to get to the data that you're interested in. Columnar formatted data has been around for a very long time. Columnar formatted databases are not new. Columnar formats are very good for analytics because you only have to look at the columns you're interested in. The data tends to compress well and vectorize well. However, it doesn't do well for transactions because ultimately you have to stitch together or combine together the column attributes into rows in order for your transactions to operate on that data. With database and memory, you get the best of both worlds. You get the traditional Oracle database row format for fast transaction processing, and you can have columnar formatted data for fast analytic processing. Now, we haven't changed the Oracle transaction or database architecture. All of your data still exists in row format. All of your existing technologies and investments in Oracle technology still run the same. Data guard and all your backups, none of that changes. And so what we do is we keep the data simultaneously and transactionally consistent. So you get to pick and choose the objects you want to populate in the column store, in the in-memory column store, in that columnar format. And then the optimizer chooses based on cost, which format of data is it going to access? And that requires then no application changes. So database and memory is literally just a plugin. You don't have to change applications. You don't have to change the way you're currently have currently architected your Oracle databases. And so it really is the best of both worlds. And it's very simple to implement. Set one initialization parameter in memory underscore size. Then you alter tables, partitions, subpartitions, or materialized views to be enabled for in-memory. And then we populate that data asynchronously in the background in columnar format. And then later you can possibly drop your analytic reporting indexes. How do you know if you'll benefit from database and memory? Well, we have something called the In-Memory Advisor. It's free to download off of oracle.com. It works on 11.203 or newer Oracle databases. It doesn't require database and memory to be enabled. It uses your existing AWR and ASH data to mine that data and attempt to determine whether you would benefit from database and memory based on your analytic workload in your applications. It does require the database tuning pack because we're going to access AWR and ASH data. And once we do that, preferably during your actual workload, your busy periods, we'll create a list of objects, SQL statements, and an estimate on how much memory and how much benefit you would get from database and memory. The report is actually quite detailed. We'll go through and provide information about, as I said, SQL, how large or how much benefit you would get from populating certain objects in the column store. So there's quite a bit of information to help you determine whether database and memory would be advantageous in your environment. One of the things I always recommend to folks is use the latest version of Oracle database. So database in memory first came out in 12.102, but currently 19C is the current long-term release, and 21C is the current innovation release. So we strongly recommend, Oracle strongly recommends that you be on, we're planning to upgrade to 19C, and database in memory has lots of features associated with 19C that can make using database in memory in your environment much better than in previous releases. So we strongly recommend that you start with the newest or almost newest release, the 19C long-term release or 21C innovation release. Database in memory is installed as part of Oracle database. So it's not a bolt-on or an extra piece of software. It's fully integrated into Oracle database. You don't have to do anything besides installing Oracle database. And as I said earlier, setting the in-memory underscore size parameter. And since you do have to set that parameter, it's not enabled by default. So don't worry that you might be inadvertently using database in memory and not knowing it. You have to enable in memory, and then you actually have to alter tables, partitions, subpartitions, materialize use. You have to enable objects to be populated in the column store. Apply the latest bundle patch or release update. So if you are still on an older version of Oracle, say 12.102, we strongly recommend applying a current bundle patch. If you're on 12.2 or later, preferably 19C, we highly recommend you apply the latest release update, because database in memory fixes are supplied with the proactive bundle patch in 12.1 and in the release updates in 12.2 and newer. There's no point in reinventing the wheel by discovering bugs that have already been fixed or discovered by other customers and already been fixed by development. So there's just no point in doing that. I have two MOS notes here to help you. It goes over the different delivery methods for each of the releases. The newer release 12.2 and greater or 12.102, and gives you information on the latest bundle patches available or release updates. What about upgrades? So if you're upgrading to say 19C, we strongly, or whatever version, maybe you're on 11 and you're going to another, maybe 12.102, but maybe your applications require that. Be careful in the sense that take a look at all of your non-default initialization parameters. Very often folks have carried non-default initialization parameters up through different versions of Oracle database because they had a problem many releases ago, and kind of everybody's forgotten what they were for, and so they just get carried along. Strongly recommend not doing that. In addition, any underscore parameters, unless you know exactly what they're for, we strongly recommend unsetting all of those. Database in memory depends on the optimizer and the latest features of Oracle database. And if you've set parameters that defeat the purpose or the ability of the optimizer and Oracle database to leverage those features, then you're not going to get the biggest bang for the buck from database in memory. Don't steal memory. So the in-memory part of database in memory is that you're going to allocate additional memory with that in-memory underscore size parameter that I've talked about. And that's going to get allocated within the SGA. But you don't want to steal that memory from, say, the buffer cache or the shared pool, because your existing workload's likely to suffer. So this is the in-memory part. You need to think of adding additional memory to your database server to support the objects that you're going to populate in columnar format in the in-memory column store. Now, the in-memory advisor that I mentioned earlier can help you with that. You can also use the compression advisor. The bottom line is you need to be thinking adding additional memory to support the in-memory column store. In addition to that, don't get carried away and think you're going to steal it from the PGA. Because now that you're dealing with, typically when you're doing analytic processing, you're dealing with larger data sets, you may need PGA or additional PGA for things like sorting or joins. And so you don't want to shortchange yourself by reducing the PGA, because you can access all of the data that you need for your analytic queries very quickly and then you spill the disk because you don't have enough area to sort the result sets that you're getting, or perhaps the join processing needs an additional memory because you're looking at larger row sets since you're doing analytic processing. One of the tips is I usually tell folks is I know memory is still not abundant, if you will, or it's still an expensive commodity, but you have to have enough, and you actually have to have more than what your actual data is going to be, because think about a DML activity causing your data to grow. Whether you add new data or you update existing data. So you need to plan for having enough memory to accommodate not only the objects you want to populate as they exist today, but also as they're going to exist or grow in the future. You don't have to plan for years in advance, but you do have to be able to understand how your data will grow during your different business cycles and plan for that, and not allocate the column store to be so tight on space that data can't continue to grow and be supported by the column store. Now your queries will still run, but if the data is not populating the column store, then we'll have to go to the row store to get that data, and that just slows down the performance that you're expecting. Fully populate your data, and that kind of goes along with the same idea of leaving enough room, but there are of course $V views that help you determine how much space you've allocated to the column store. So a view called $V in-memory area. I have a picture here that shows two pools, the 1 meg pool and the 64K pool. These two pools make up the in-memory column store or the in-memory area. And then you can determine with $IM segments what objects have been populated in the column store, and one of the key attributes is this bytes not populated column, which tells you that an object is fully populated in the column store. So if it wasn't fully populated, then that bytes not populated column would be non-zero. Kind of along the same lines, you could actually see population as it's occurring. So when you first bring up the database and enable objects to be populated in the column store, we'll populate those objects, fully populate them. I should mention that the column store is not a cache, it is a store. So we're going to fully populate the objects you've identified or enabled for memory into the column store. And then the $IM segments view can show you not only if the object didn't fit in the column store, in other words, bytes not populated is greater than 0. But in this case, you would actually see, if you queried this $IM segments view repeatedly, you would see the bytes not populated value going from what it currently is to 0 as that data is populated. So you can kind of manage population by viewing that $IM segments view. One thing to note though, RAC is a little bit different. Since we'll talk a little bit about RAC, but since RAC is a scale out environment, we're going to show you just the amount of memory used for each of the RAC instances. What if you don't have enough memory? If you don't have enough memory, you can use the compression advisor to estimate how much memory your objects will require. There are multiple levels of compression, so you can choose to compress your data at a higher compression level and be able to fit more data into the column store. So that's a good tool to use, especially if you're tight on memory. I mentioned the ability to do compression. Typically, we get from anywhere from a 2x to a 20x compression rate. There are multiple levels of compression for DML, for query low, which is the default, for query high, for capacity low, and for capacity high. So it is possible to vary the levels of compression. You could do this at the object level, even at the column or columnar level. In addition, you can exclude columns as well. Since columns can be excluded, there is a couple caveats to that. If you decide to exclude a column, notice here I've excluded delivery note. If I then have a query that accesses delivery note as part of the select list or maybe in a where clause, then the query will have to run in the row store. Now in 21C, we have a new feature called in-memory hybrid scans, where if delivery note was just in the select list or a projection column, we could actually run the query in the column store and then just go pick up the individual column values or the values associated with the rows that were returned from the query from the row store. So we actually get what we call a hybrid scan, or being able to use both column store value and the row store. Does database in memory work with rack? So I mentioned rack a few minutes ago. The way rack works is we actually allocate a column store on each of your instances in the rack cluster, and then we scale out the data or distribute it across those rack clusters or rack nodes. What that gives us then is the ability to, if you say have 100 gigabytes allocated to the column store on one node, if you had 4 nodes, you could have 400 gigabytes of column store. Now, in order to access that data, we have to use parallel query because we don't ship the IMCUs or the in-memory data across the interconnect like we do with the row store. So what we have to do then is access that data across each of the column stores in this example, our 4-node rack cluster, and that means we use parallel query to do that. We support several levels or methods of distribution. Row ID range, which means for data that's not evenly distributed, for instance, that's maybe not hash partitioned, you would probably use distribute by row ID range. It is possible to distribute by partition and by subpartition. Ultimately, the goal is to get even distribution, since we're going to be using parallel query to access that data across the different column stores. In addition to that, since we are going to use parallel query, we need to have a degree of parallelism at least as great as the number of instances in or that have data in the column stores. Think of it as our 4-node or 4 column stores across our 4 rack nodes. We need to have at least one parallel server process on each of those 4 nodes. Now, when we first started with database in memory in 12.102, we accomplished this with auto DOP. In other words, we required auto DOP to be enabled in order to get a query, a parallel query process scheduled on each of the nodes to access that data. Now, all we require is you have a DOP at least as large as the number of nodes. In this case, it would be a DOP of 4. And then you can set that either with auto DOP, which would be the Oracle recommended way, or you could set a manual DOP level, either at the table level or perhaps at the SQL level. And so the idea here is just that since we're using parallel query, we need to be able to access the data on each of the 4 nodes in our example here. How does database in memory work with other database features? So Exadata. Database in memory has some unique features to Exadata. One is flash. So we not only support database memory in the column store in DRAM, but on Exadata, we also support the database memory columnar formats on the Exadata Smart Flash Cache. So this now gives you the possibility of having terabytes of columnar data. Think of it as tiered data where you can have some data in DRAM in the column store and some data in columnar format on flash on Exadata. So that gives you the ability to have much larger columnar data, columnar footprints to be able to run even larger analytic workloads. And in addition to that, we support in-memory duplication. So since most rack environments have, since most Exadata environments have rack, if you have multiple nodes, it's possible to mirror your in-memory data across those nodes so that if one node were to go down, that data would still be in a surviving node and you wouldn't affect your SLAs for your analytic queries. In addition to that, we also support active data guard on Exadata. So it's possible that you might have a standby database and run your analytic queries against the standby database, reducing the workload requirements for the primary database. In addition to that, we run whether it's Exadata on premises or Exadata in the cloud or Exadata cloud at customer. So anywhere Exadata, you're running Exadata, if you're running database in memory, you can take advantage of these unique features. In addition to that, database in memory is fully integrated with multi-tenant. And since in 21C and beyond, multi-tenant databases or container databases are going to be the only way that Oracle database is supported, database in memory runs just fine with container databases. We allocate the column store at the CDB or container database level. Then each of the PDBs can access or allocate objects in the column store just for their PDB usage. And whether you have one or more PDBs, you can leverage database and memory with that. That gives you the advantage of having multi-tenant and then also being able to use database and memory. So how do you know which queries will benefit from database and memory? Now you can run the database and memory, the in-memory advisor, but what I usually tell folks is for a non-trivial amount of rows and execution time, when a significant amount of your execution time for your query is spent either accessing data, joining data, or group by aggregations of data, then database and memory is going to provide a significant benefit to your analytic workload. But you need to target the right workloads. So we've talked about analytic workload. So we're not going to speed up transaction processing in the sense of inserts, updates, and deletes. Now, if you're able to reduce your index requirements, then we can speed up your workload in the sense that that Oracle database won't have to maintain those indexes, but we're not going to directly speed up inserts, updates, and deletes because database memory is focused on scanning and filtering data, joining data, and aggregating data, as I mentioned. So if you're spending a significant amount of your time on network, SQLnet traffic, parsing, sorting, running PL SQL code, doing row by row processing, then database and memory isn't going to speed up that functionality. What really database and memory is all about, again, is processing data in the database and during the scan of that data, again, accessing, joining, and group by aggregations. So how do you know if you made use of the column store or database and memory provided benefit to your queries? So we recommend SQL Monitor active reports. Time-based optimization allows you to see not only how much time your query ran for, which is obviously going to be the biggest benefit to using database and memory, which is faster response time. But in addition to that, seeing where in the execution plan you had benefit. And if you notice here in the bottom section, we did a table access in memory full. And if you hover over the activity bar, the percent of activity, it'll tell you that we spent that time CPU in memory. And basically what I'd like to tell folks is the fastest query you can execute is one where all of the work was done during the scan operations of the data. In other words, accessing that data, joining and aggregating that data. So that's how you can tell a very simple way of saying, not only was my query faster, but I can see that I used database and memory and that reduced the time that query previously ran in. And so that's where I got my benefit. In addition to that, we have many statistics, both session level statistics and then system level statistics, if you will, that can tell you not only during your query, how much work was done in memory, whether during the scan, how many rows might have been projected so that we didn't have to bring all the rows back. We're able to do filtering and group by aggregations during the scan of the data. Or maybe in an AWR report, you can see the overall workload, how much population activity went on, how much repopulation occurred. So there are statistics to help you, just like with any other Oracle database feature, determine how much benefit you got and how much work is going on based on database and memory. In addition to that, on our blog, we have some more detailed descriptions of some of these key statistics. So if you want to go back, most of them are documented in the reference guide, but we've also done some blog posts that highlight some of the key statistics and what they mean based on running your queries or running queries in the Oracle database. What's new? So database, as I kind of mentioned earlier, database and memory was first introduced with 12.102. In 12.2, 18C, now 19C, we've added a lot of new features, some performance related, some management related. In other words, things like automatic in memory, being able to start to automatically manage objects being populated in the column store, either being populated or evicted. So they're making room for more active objects, external table support. And then in 21C, we've previewed a whole bunch of new features based on our converged database model. We've got support for spatial, full text columns. I mentioned hybrid scans, some real big performance benefits. And then we've further enhanced automatic in memory. And the path we're headed on is to make the column store self-managing so that you don't even have to decide what objects to populate. We'll populate those automatically for you and manage that space. And with that, all I wanted to conclude with was letting you know that we do have a blog, blogs.oracle.com/memory. In addition to that, we have a resources page. So if you're interested in database and memory, if some of the things I've talked about you'd like to explore additionally, we have technical briefs. We have our Ask Tom office hours sessions where we've gone through and done demonstrations and talked about various features in Oracle database. And if you want to try it out for yourself, we have our Live Labs environment. So there's a link there to our Live Labs. So you could go run database and memory for yourself on Oracle Cloud and try it out with some of the queries that we have for our SSB schemas and see just how fast database and memory is. So with that, I'll conclude and thank you very much for your time.